Welcome to the next session. We start the session with question number 56, classroom workbook, chapter number 4, complex variables. Question number 56. If C is a circle of radius R, C is a circle of radius R with center Z0. That means the circle C is modulus of Z minus Z0 equal to R in the complex plane. And if n is a non-zero integer, here n is a non-zero integer value. So in that case, what is integral dz by z minus z0 whole power n plus 1? We need to find out this. Now when you look at this, what is my contour C? So actually this contour is modulus of z minus z0 equal to R. So this is actually integral 1 by z minus z0 whole power n plus 1 dz over the contour. Contour is modulus of z minus z0 equal to R. Here z0 is z0 only. Now when you replace z by z0, modulus of z0 minus z0, 0. 0 less than R. So therefore it lies inside the circle. Therefore here the power is n plus 1. So here what is f of z? F of z is 1. Constant function, numerator. So by Cauchy's integral formula, this is 2 pi I by n factorial into nth derivative of f at z0. But this is a constant function, its derivative is 0. So therefore this is 2 pi I by n factorial into 0. So the value of contour integral is 0. So option B is right answer. 7. If C is a circle, mod z equal to 4 and f of z equal to z square by z square minus 3z plus 2 whole square, z square by z square minus 3z plus 2 whole square, then integral f of z dz over C equal to, options are given like this. Here options are, using options also we can able to answer this. So option A is 1, B 0, C minus 1 and D is minus 2. So C is a circle defined by mod z equal to 4 and f of z is this. We need to find integral f of z dz over C. Now when you look at this, the denominator of f of z is z square minus 3z plus 2 whole square. This I can write it as z square by z minus 1 into z minus 2 whole square. So this is z square divided by z minus 1 whole square into z minus 2 whole square. So therefore what are the poles of this function? 1 and 2. For this function 1 and 2 are poles, but the problem is they are poles of order 2 and both the points belong to this circle. 1 and 2 lie inside the circle. 1 and 2 lie inside mod z equal to 4. Therefore this becomes 2 pi I into residue of f of z at 1 plus residue of f of z at 2. So this is my value. Integral is 2 pi I into residue at 1 plus residue at 2. But 1 is a pole of order 2. 2 is a pole of order 2. So we need to apply case 2 for both the poles. But it is not required because when you look at the options, suppose if the sum of residues is a non-zero expression. If the sum of residues is a non-zero expression, then answer will be 2 pi I into some non-zero number will be there. Okay. That will be okay. But if it is a non-zero number, answer will be multiples of 2 pi I. So there is no expression which is multiple of 2 pi I. Suppose if the sum of the residues is non-zero constant into 2 pi I. So again it is a multiple of pi I. But there is no expression in the answer which is a multiple of pi I. Therefore the sum of residues should not be equal to 0. It's a wrong statement. Therefore sum of residues will be equal to 0. Therefore the answer is 0. So it is option B. Did you understand this? I repeat once again. Suppose if actually in this case the result is 2 pi I into residue at 1 and residue at 2. Now residue at 1 can be calculated by applying case 2 of residues, because 1 is a pole of order 2, 2 is a pole of order 2. So we need to find residues using case 2 for both the poles 1 and 2. It takes some time, but this can be solved using by options. If the sum of residues is a non-zero constant, then 2 pi I into non-zero constant must be multiple of pi I. There is no option which is a multiple of pi I. So therefore the sum of residues must be 0. So therefore the answer is 2 pi I into 0. It is 0. Not this. Even for the last question, you can cross check it. You can easily find residue at 1 and residue at 2. Add both the quantities, you will get 0. You can easily verify. Next question. Question number 58. The absolute value of integral 5z cube plus 3z square divided by z square minus 4 dz over the circle modulus of z minus 1.5 equal to 1 in the complex plane up to 2 decimal places. So we need to find this contour integral and apply modulus sign. Absolute value means modulus up to 2 decimal places. Now look at this. Here what is f of z? F of z is new total function. So this is 5z cube plus 3z square divided by z square minus 4. So this is 5z cube plus 3z square divided by, this denominator can be written as z minus 2 into z plus 2. Therefore 2 comma minus 2 are singular points of 2 comma minus 2 are singular points of f of z. But when you look at these two, modulus of 2 minus 1.5, 0.5 less than 1. So it lies inside the circle. Minus 2, modulus of minus 2 minus 1.5, minus 3.5. Modulus of minus 3.5 means 3.5 which is greater than 1. So in this case 2 lies inside the circle. 2 lies inside the circle. Modulus of z minus 1.5 equal to 1. But minus 2 lies outside the circle. Modulus of z minus 1.5 equal to 1. 1 inside, 1 outside. So you find residue of this function only x2. So what is the residue of the function f of z at 2? Here 2 is a pole of order 1 only. So this is given by limit z tends to 2. Z minus 2 into f of z. You can eliminate z minus 2. This is 5z cube plus 3z square divided by this z plus 2. So this is 5 into 2 cube 8 plus 3 into 2 square 4 divided by 2 plus 2 4. So this is 40 plus 12, 52 by 4. So this is 13. So therefore this integral I call it as I. Therefore by Cauchy residue theorem, this I is 2 pi I into residue at 2. This is 13. So therefore this value is given by 26 pi I. But we need to find modulus of this. So modulus of I is modulus of 26 pi I. But modulus of I is 1. So this is 26 pi. But the value of pi is 3.14. So you simplify this value, take the value up to 2 decimal places. So it will be close to above 78 and below 79, I think so. Integral z plus 1 divided by z square minus 4 dz over C, where C is a counterclockwise circle of radius 1. See here, C is a counterclockwise, not anticlockwise. Counterclockwise circle of radius 1 and center equal to minus 2. That means the equation of the circle is, that is C is mod z plus 2 equal to 1, because this is modulus of z minus of minus 2 equal to 1. So it is in the form modulus of z minus a equal to r. Center is a comma 0, so minus 2 comma 0 and radius is 1. So here center is given as minus 2, radius is 1. So the circle equation is modulus of z plus 2 is 1. Because when you write this as modulus of z minus a equal to r, plus 2 becomes minus of minus 2. So this center becomes minus 2 comma 0. They are not giving 0. Center you can take minus 2 directly. So therefore the equation of the circle with center minus 2 and radius 1 in the complex plane is modulus of z plus 2 is 1. But they were asking counterclockwise direction. Calculate by using a residue theorem or integral formula, whichever is flexible for you, and add minus symbol. Okay. So this is basically I, for example. Now here f of z is z plus 1 divided by z square minus 4. So this is z plus 1 by z minus 2 comma z plus 2. So the singular points are 2 comma minus 2. Now my contour is this. Suppose when you replace z by 2, 2 plus 2 is 4, 4 greater than 1. When you replace z by minus 2, minus 2 plus 2, 0, 0 less than 1. So 2 does not lie inside the circle, but minus 2 lies inside the circle. Therefore, I need to calculate the residue of this function only at minus 2. So therefore, this is limit z tends to minus 2. So limit z tends to minus 2, z plus 1 divided by this is z minus 2. So replace z by minus 2, we get minus 2 plus 1 divided by minus 4. So therefore this is 1 by 4. So it is 0.25. Now residue of f of z at minus 2 is 0.25. Therefore this integral I is actually 2 pi I into residue of f of z at minus 2 only. So this is 2 pi I into, of course you need not simplify to decimal value, this is 1 by 4. So this is pi I by 2. But basically this is counterclock, this is anti-clock direction. So counterclock integral is, so what the direction they mentioned? Counterclock direction. So therefore counterclock direction value is, counterclockwise means anti-clockwise. So anti-clockwise means original value only. So counterclockwise integral I value is pi I by 2. Counterclock means anti-clockwise direction. So you take pi I by 2. If it is clockwise, minus pi I by 2. If it is anti-clockwise, original value pi I divided by 2. So option A is right answer. So here the contour is given using a coordinate system, x-axis, y-axis. The contour is given like this. Here this is moving along anti-clockwise direction, 1 inside. But here contour is moving in the clockwise direction, this is minus 1. So therefore we need to find 1 by pi into 1 by pi I into integral dz by z square minus 1 over c. So when you factorize this, you will get 1 and minus 1. So 1 and minus 1 are singular points. What is f of z? 1 by z square minus 1. 1 comma minus 1 are singular points, both inside the contour. But regarding 1, contour is moving in the anti-clockwise. But regarding minus 1, it is moving in clockwise direction. This is anti-clock, this is clockwise. So therefore, this can be written like this. 1 by pi I into integral 1 by, this can be factorized like this. 1 by z minus 1 divided by 1 by z plus 1 dz over the contour C. But when you simplify this, you will get 2. So divide with 2. So simplify this. You will get 2 by z square minus 1. But it is 1 only. Divide with 2. So this is 1 by 2 pi I into integral 1 by z minus 1 dz over C minus 1 by 2 pi I into integral 1 by z plus 1 dz over C. But this integral I call it as I1. This in second integral I call it as I2, and original integral I call it as I. Now let us, I is nothing but I1 minus I2. I is nothing but I1 minus I2. So let us calculate I1. But what is I1? That is related to 1 only. But 1, this is contour is moving in along anti-clock direction. So I1 value is, by Cauchy's integral formula, this is f of 1. Because this is 1 by 2 pi I into integral f of z by z minus z naught dz over c. But 1 inside the circle, so f of 1 is a constant function. So it is 1. Now I2 value, but actually this is a minus 1. But for minus 1, contour is moving in the anti-clock, counterclockwise, clockwise direction. So minus will come. Already minus is there. So therefore I2 is minus f of minus 1. Because here it is minus 1. So it is a constant value. So this is minus 1. So therefore the value of I is I1 minus I2. This is 1 minus of minus 1 and this is plus 2. So don't confuse with this. Here it is z0 is minus 1, but for minus 1 contour is clockwise direction. So you will get minus sign. Already minus is there. We have applied Cauchy's integral formula for 1 and Cauchy's integral formula for minus 1. This is f of z and this is f of z. So 1 by 2 pi I into integral f of z by z minus z0 dz is what? F of z0, f of 1 minus this is f of minus 1. But for second integral again minus will come. So that this is first integral is 1, second integral minus 1. So therefore I is I1 minus I2, the value is 2. Just this minus comes because the contour is moving clockwise direction for minus 1. This. So this minus symbol we are getting because the contour C is moving clockwise direction for minus 1. That's why we are getting minus extra for minus 1. But regarding 1, you will get plus sign only because it is anti-clockwise direction. Last concept, Cauchy's theorem. Very simple, just one line statement. Suppose I want to find integral f of z dz over c. So till now we have handled many questions like this. One is integral f of z by z minus z naught. Second category is integral f of z by z minus z naught whole power n plus 1. By using residue theorem, integral will be reduced to integral f of z dz over c. Suppose if it is analytic at all points inside and on the boundary of the circle C, then the integral value is 0. If it has no singular points inside the circle, inside the contour, its value is 0. Note this. Cauchy's theorem. Let f of z be a function. Let f of z be a function which is analytic at all points inside and on a simple closed curve C. Let f of z be a function which is analytic at all points inside and on a simple closed curve C. Let f of z be a function which is analytic at all points inside and on a simple closed curve C. Then integral f of z dz over c equal to 0. Then integral f of z dz over c equal to 0. So chapter 4 is finished. So in the next session we start chapter number 5. Thank you so much.